Okay, let's look at number 7 in section 5.1, and it's another differentiation problem where we have to use implicit differentiation, and we notice that on the left hand side we have this tangent of x squared plus y, and so that's a chain rule. And then over on the right hand side it looks like we have a bit of a product rule, so get to practice both of those. So let's take the left side. Of course, the derivative of just tangent is secant squared, and we're not going to touch the angle at first. And then the derivative of the angle is 2x plus the derivative of y is 1, so it's 1y prime. And on the right hand side we have, if we make that equal to f and y to the third power equal to g, and we use the product rule on that, we're going to get that f prime is equal to 2 and g prime is equal to 3y squared dy over dx, or we just put y prime up there. So putting the right hand side together, we would get f prime g, so we have 2 y cubed plus f g prime 2x minus 3, and g prime is 3y squared times y prime. And let's see, so remember our goal is to solve for y prime, so we have a quantity of one of them here, and we have a y prime here. So in order to do that, well, we have to somehow separate it and isolate y prime over here on the left. So we could do it a number of ways. The first thing we could do would be to distribute this 2x plus y right here. This whole term, we could distribute it back to that secant squared. So that would look like 2x secant squared x squared plus y plus y prime times secant squared of x squared plus y. And on the right hand side we still have 2y cubed, and we could distribute our 3y squared y prime to the right here, back to this guy. So we would have 2 times 3, we would have 6x y squared y prime minus 9 y squared y prime. And then we could collect all of our terms, all the y primes on the left, and everything else we can move over to the right. So let's see if we can come up with a plan before we do that. So there's a y prime, there's a y prime there, and there's a y prime right there. So let's start this by moving this term over to the right, and we'll leave this term on the right. So doing that, we'll rewrite the right hand side first. We already have 2y cubed there. Now we have a minus 2x secant squared x squared plus y on the right. And over on the left hand side we already have our y prime, secant squared, x squared plus y. That's this one. And if we move this one over, we have positive 9 y squared y prime. And if we move this one over, it's going to be subtract 6x y squared y prime. Okay, so maybe in order to save space, let's first of all emphasize this point right here. We have a y prime here, a y prime here, and a y prime there. So we can, in essence, just factor that out. And when we factored it out, I don't think I want to rewrite this whole thing. We'd have y prime, and then we would have our secant squared, our 9y squared, and a 6x y squared right there, right? So, and then we would do what? We would divide all that stuff out. So in order to save a little bit of time and space, I'm going to just rewrite the solution right here and see if we need to clean it up a little bit. So this entire right hand side is going to end up being our numerator, and we would have 2y cubed minus 2x secant squared, and the angle is x squared plus y. And then on the bottom we're going to have secant squared x squared plus y plus that 9y squared minus 6xy squared. Okay, and certainly I wouldn't waste any more time trying to find any kind of shortcut on here or any kind of simplification. This looks pretty nasty as it is. So anyway, hopefully this helped, and yeah, this is about as messy as you'll get in this class. So good luck with the rest of the set, and take a look at my video for number 10.